This is lesson 2.2, and we're going to be learning about slope. Okay, so slope can be defined as a ratio of change in y values to the change in x values. So it's a number that represents the ratio between the change in y and x. Another way that you can put it is, went too far. Another way that you can put it is you can find the slope by finding the change in y, so how the y values are changing, and putting that into a fraction on the top, where the bottom of the fraction is the change in x values. That's also noted by this. Notice that these two things are saying the same thing. These triangles represent change in, right? So this means change in y over change in x. What we're really going to be focusing on in this lesson, though, are these two highlighted. We're going to be looking at the rise over run method, and we're going to be looking at the formula that you can plug in when you know 2 points on the graph. And that's what this means right here, where x1, y1, and x2, y2 are solutions. So any 2 points that you can find on the graph, you can plug them into this formula, right? And then you'll get the slope. Okay, so let's look at these methods. We're going to take an example here. And here you can see everything highlighted in blue represents the rise over run method, and everything highlighted in yellow represents the formula method, right? So first off, let's look at the rise over run. So if you're going to figure out the rise over run, you need to know which directions mean which. So first off, positive directions are going up and going to the right. Those are positive directions. Another way that you could think of this, and maybe I'll do this in pencil, is if you start with this point here and you choose to go up and figure out what your rise is. So I rose by 4 and then I ran by 2, right? I went to the right by 2. So I plug those in, 4 over 2. However, the other way that you can think of this is if you don't want to start at this point, let's say you want to start at this point. So if I'm trying to get from this point to this point, you're going to kind of do the opposite thing. So you're going to measure how far down you go. And if I'm rising down, that doesn't really make much sense. So it's actually the opposite of rising. So this would be a rise of negative, or not 2. I'm glad I'm using pencil. A rise of negative 4. So I'm actually thinking about going down 4 steps from this direction. Now this might look like you're getting the opposite answer, but if you stick with it, you can see what happens here. And then I'm going to the left 2 steps. So my run is negative 2. Keep in mind, going to the left is negative, but going to the right is positive. So here we have opposite answers, a rise of negative 4 and a run of negative 2. Now you might be wondering, so which answer is right? Well, the answer is both of them. You'll get the same answer both ways, because think about it. If I've got positive 4 over positive 2, that equals negative 2, or not negative 2, that equals positive 2. If I take the rise and run that I got from using my pencil here, so I take rise over run, and I take the negative answers that I got by following the pencil, I'll have negative 4 over negative 2. But what happens when you divide a negative by a negative? You get a positive. And 4 divided by 2 gives me an answer of positive 2. So notice, either way you go, if you go this route from this point to this point, you're going to get a positive 2. But if you go from this point to this point and you go down and to the left, you're going to get positive 2 as well. So it really doesn't matter which method you use here or which direction you go from. You're going to get the same answer no matter what, right? Okay, so now let's look at the formula method. So if we're using the formula method, let's say you don't actually know the graph and all you know are the points, right? And I wrote down the 2 points that we're looking at here. And all you have to do is you have to assign which point represents what. Is this going to be your first set or second set? And from here you can see that I labeled the one on the left my first set. See how there's a 1 next to the x and y? So this is my first set, and then that means that by default this one has to be my second set. It really doesn't matter, because you'll find it's the same idea. It really doesn't matter which one you choose is 1, which one you choose is 2. As long as if you're saying this is 2, both of these here have to be 2. If you're saying this is 1, both of these have to say 1, right? You can't have them intermixed, or else you end up getting the wrong answer. You're going to get the opposite answer of what you want. Okay, once you've labeled them and you've decided which one's which, now you plug it into the formula you were given, y2 minus y1s. Notice that that's going to help us find the change in y. So how did the y's change? Well, the only way to find that out is by subtracting the two values. So we plug in y2 minus y1 is a negative number, so it's minus a negative, which creates a positive situation, 2 plus 2. And then we've got x2 minus x1. x2 we chose as 1, and x1 we chose as negative 1. So now we got 1 minus negative 1. Once again, that's minus a negative, so we get 1 plus 1. So here we get 4 on top and 2 on bottom, which if you divide 4 divided by 2, you get 2. Notice that both methods give you the same answer. Both of them involve dividing 4 by 2. It's your job to figure out which method is going to be easier, right? Okay, let's go ahead and look at the different types of slopes that we can have. So first off, let's focus on the green values. So the green here represents a positive slope. So this is the reason why we're going over this, is because this helps us check to make sure we got the correct answer. So your positive slope, if you're reading from left to right, should be going upward, right? So it should be going upward if you're reading from left to right. If you start reading from right to left, you'll notice that it's actually going down. So you need to figure out which direction you're reading from. Well, we read from left to right. That's naturally how we read. So it makes sense that this would be a positive slope here, okay? So another thing that's important to notice is that it's going to be positive where we have two numbers being divided here, and both numbers have the same sign. So they either both have negative signs, making a positive slope, or they both have positive signs, making a positive slope. Or sorry, positive signs, making a positive slope. Right? So both give you a positive answer. Now, the time that you get a negative slope is if reading from left to right, the graph is going down, right? And then that happens when one of your values is negative and the other one is positive. So notice here, you could either have the top number be negative and the bottom number be positive, or the top number be positive and the negative number the top number be positive, bottom number be negative, right? So as long as if they have opposite signs, okay? And then thirdly, we have a slope of 0. This happens when you have 0 being divided by any number. Any number does not matter. You can have 1,562. 0 divided by 1,562 is still going to be 0, right? And visually, we can see that when we get a slope of 0, the graph is what we call, and go ahead and add this to your notes here. The graph is what we call perfectly horizontal. Okay? This is a horizontal graph. Horizontal, if you think about the word horizontal or the word horizon, you look at the horizon and it's a straight line, right? When you're looking at the sunset, the hill looks like a straight line, right where the sun is coming up. So that's how I remember it. Horizontal horizon, right? It's going to be left to right, okay? Slope is 0. And then you end up with an undefined slope when you get n divided by 0. And the reason why you get undefined is because this is not a possible situation. There are no situations in real life where this can actually happen. I'll give an example. So let's think of this as time, the x values as time, and the y values as distance. So if I'm traveling a certain distance, let's take these ones for example. So if I started out this far away from home in the negative y values, and time passes by, I'm getting closer to home, and now I'm positive distance, right? And then the opposite happens here. I start out away from home, then I get closer to home, away from home, right? So as time is passing, you're moving, right? And that makes sense. However, for a slope of 0, this would actually represent time passing by, but you're not going anywhere. You're not changing your distance at all. It's as if you were just sitting in your car for an hour doing nothing. You would just be sitting in one spot. Time is still passing by, so we have to draw something, but you're not moving up and down, so you're not changing your distance at all. Now in this case, we kind of get a weird situation where time isn't actually moving at all. We don't see any of the part of the graph on this side, but suddenly we pop into existence here. Not only do we pop into existence, but I'm over here, 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 here. I'm all over the place all at once, right? So this is an impossible situation. If you don't understand what I'm talking about here, that's totally fine. You don't have to understand what I'm talking about. It's just the best way that I know how to describe why graphs that are what we call, go ahead and add this to your notes, vertical, perfectly vertical, create impossible situations. Another way you can think of it is if you have any number being divided by 0, you can't actually break 0 up into a number. It's impossible. So you can't divide a number by 0. It's impossible to do that, okay? If you don't understand why or anything, you're just going to have to trust me. Okay, what I want you to do is I want you to go ahead and work on page 53 through 54 and do numbers 9 through 14 all, and we'll come back in the next video. Okay? Go ahead and work on that.